6.5, solving special types of linear systems. This is going to be exactly what we just did on the summative and for the past couple weeks, except a little twist. So sometimes a system has no solution. So when a system has no solution, we say that it is inconsistent. Okay, and these mean the same thing. If you want to say no solution, or if you'd rather say inconsistent, I don't care. They're interchangeable for this. So let's see what it looks like when you solve a system and you get no solution. Okay, so number one, we're going to solve by elimination. And if you were going to do elimination, I would say most of you would probably multiply one of them by -1 because that would eliminate one of the variables. All right, so if we distribute in a -1, we get -3x, -2y equals -2. And I'm going to leave the second equation the same. 3x plus 2y equals 10. All right, and let's see what happens. So if you were going to do elimination, now that we have opposites, we're going to add going down. -3 and +3x cancel. -2y plus +2y also cancels. So on the left-hand side, we're left with a big old 0. If everything cancels, it's like a big 0. And then let's add the right side. -2 plus 10 is 8. Okay, so if everything cancels and there's no variable left to solve for, you look at the numbers that remain and you see if it's true or false. Is 0 equal to 8? And if it's not, then your answer is no solution. And there's no thing to plug it in for because there is nothing to solve for. It's no solution. Or you could have written inconsistent. All right, let's look at number 2. First of all, I'm noticing a typo that this should be a minus sign, not an equal sign. All right, so to graph, we begin with the B and move with the M. So begin at -1, and the slope is down 3, right 2. I'm also going to go the other direction, up 3, left 2. Okay, so that's my first line. And then the second line, we're going to begin with the B at 5, and also go down 3, right 2. Down 3, right 2. And it's better if you have something straight, but as you guys notice, the lines are never going to cross. They're parallel. So if there's no intersection, then this is what it looks like for there to be no solution when you graph. Parallel lines. Okay, the next one is, what if they have every solution, infinitely many? We call that a dependent system. And that is when the system has infinitely many solutions, meaning it crosses everywhere, meaning the lines are on top of each other. Okay, so let's see what that looks like when we do substitution first. Okay, so normal substitution would say, well, if I know that y equals 1/2 x plus 2, then I'm going to replace y with that. So I'm going to make a substitution. So I'm going to rewrite this, x minus 2 times, but instead of writing y, I'm replacing it with 1/2 x plus 2. And then we're going to finish it off equals -4. Remember, just old substitution, nothing new. And then you're going to distribute the -2, and we get x minus 1x, and then if you distribute it here, you get -4 equals -4. And then we're going to add like terms, but what does x minus x do? They cancel, so that's like a 0. And again, if the variable cancels, you're left with only the numbers left over, and we're left with -4 equals -4. And you would say, well, that's always true. So this would be one with all solutions. So you can write all solutions, you can write infinitely many, or you can write dependent. Those all mean the same thing here. Okay, so that's what it looks like when it's all solutions. Let's see what it looks like when you graph and it's all solutions. So begin with the b, which is 2, and then slope is up 1, right 2, up 1, right 2. Okay, so that's our first line. And then line 2, begin at 2, and slope is up 1, right 2, up 1, right 2. So notice how they're on top of each other or they're the same line. Well, that means that they have every point in common. So this one's also all solutions or infinitely many or dependent system. So it's really obvious when you're graphing it if they're like the same line or on top of each other. Okay, so just to recap, we did no solution. We did when a system has all solutions in common. And then before this, we did when there is one solution. So we don't have to review this one. When there's one solution, it's called a consistent system. So when a linear system has only one solution, we say that it is, I'm sorry, this should say consistent. When there's only one solution, we say the system is consistent. And this is what was on the summative. If we know a system has one solution, we need to identify the ordered pair. Okay, so these are ones where you're actually going to get an answer. Okay, so we don't need to review this because we've done this already. Okay, so I would say if you guys are feeling good, you can stop because we still have a whole day to practice all these. But if anybody wants, I'm happy to do maybe one or two more just to see kind of what's going on. So feel free to stop if you would like right now. If you want one more, we're going to do one graph and one solving. So tell whether the system has one solution, no solution, or infinitely many solutions. Okay, so to tell by looking at a graph, it's pretty obvious. If the lines never cross, they're parallel, what would you guys say? And hopefully you're saying no solution, because if they don't cross, they're not going to have an intersection, which means they're not going to have a solution. Now, number 2, you notice that they do intersect, but only at one point. So which one do you think is right? Well, hopefully you said one solution, because the intersection point is the one solution. One solution. All right, I'm going to solve one of them just to practice. And let me pick, let's do number 5. All right, so this would be a great time for you guys to pause and try it. We're going to solve it and see if it's the normal one solution or no solutions or infinitely many. Okay, now you guys can pick. Do we want to do elimination, substitution, or graphing? I would say elimination, and I would multiply everything by 2 because I'm going to say that a positive 10 will then cancel with a negative 10. So I'm going to do elimination. So if I triple distribute, on top I get 10x plus 2y equals negative 4. And on bottom, I'm going to leave it the same. Negative 10x, negative 2y, positive 4. And then when I add going down, let's see what happens. 10 and negative 10x cancel. 2y and negative 2y cancel. So on the left side, I'm left with a big 0. And on the right-hand side, negative 4 plus 4 also cancels to 0. Okay, so when everything cancels, it's either going to be all or none. Does 0 equal 0? Is that true or false? Well, 0 does equal 0, so that means that all solutions work. When this equation is equal, it's infinitely many. Infinitely many. Okay, so I think I'm going to stop there and we're going to review this tomorrow. So that should be good. Thanks for watching.